Welcome back to the deep dive. Today, we're looking at something really fundamental in electric mobility, maybe a bit understated. It's this quiet, but really urgent hunt for alternatives to critical raw materials, specifically inside the motors themselves. We're going, under the hood, beneath the chassis, to see how a new generation of engines might be tackling geopolitics and environmental waste all at once.
That really is the core challenge, isn't it? Our sources today, they center on a company called Advanced Electric Machines, or AEM, and they've got this pretty groundbreaking magnet-free motor technology. So for this deep dive, we're looking at two key things for you. First, the technical side, what are the advantages? And crucially, the sustainability angle of this rare earth-free design.
Right.
And second, what's its potential really for mass adoption? Can it scale up across the whole auto industry?
Yeah, because the problem it solves is, well, it's massive. Right now, high-performance EVs, they lean really heavily on permanent magnets. And those magnets use critical rare earth elements.
Right, materials that are expensive.
Expensive. And the supply chain. It's almost entirely dominated by one region, China. Plus, getting them out of the ground is notoriously toxic. Huge amounts of hazardous waste. It's a genuine headache, both for supply chains and the environment.
It really creates a paradox, You're trying to build a green vehicle, but you're depending on this very ungreen extraction process in a market that can be pretty volatile.
Yeah.
So getting free from that bottleneck, that's kind of the next big race in automotive tech, isn't it?
Which brings us neatly to AEM. What they're pioneering is electric motors made mostly from, well, simple steel and aluminum.
Steel and aluminum.
Yeah, they're completely eliminating the rare earth magnets. And in quite a few designs, they're even moving away from using copper.
That sounds counterintuitive. How do you ditch the main thing? Giving a high-performance EV its punch, its torque, and still somehow improve performance. That's a huge engineering challenge.
It is. It's a bold claim, absolutely. You'd think, okay, remove the permanent magnet field, you lose that instant power EVs are famous for.
Exactly. That immediate off-the-line acceleration.
But AEM's claims, based on the sources we've looked at, they aren't just about matching current standards. They're suggesting they can actually surpass them. For example, they're talking about up to a 45% better power-to-weight ratio for passenger car models compared to what's out there now. That's a big leap in efficiency.
Wow, 45%. And that number isn't just abstract, right? That hits right at the heart of range anxiety. Lighter, more efficient.
Precisely. And the technical side explains a bit of the why. Permanent magnet motors, they're great for low-speed torque, sure. But they often have issues with electromagnetic drag, these sort of windage losses, especially at higher speeds, like on the highway.
Okay, so when the motor's spinning really fast.
Exactly. By using a magnet-free design, it's likely some kind of synchronous reluctance or maybe an induction motor variation. AEM can optimize it specifically for that high-speed efficiency.
So maybe they trade a tiny bit of that peak low-end torque, which most drivers don't use all the time anyway, for much better efficiency when you're just cruising along.
That seems to be the idea, and better efficiency means better battery life. Simple as that.
Right.
AEM CEO, James Widmer, he's been quite direct. He said these new motors are superior to what we are replacing. And the figure that really jumped out, the headline number, is the claim of up to a 12% range improvement for EVs using this tech.
12%. That's massive in the EV world. You compare that to the gains we see from battery research. Billions spent for maybe, 3 or 4% improvement year on year.
Yeah.
Getting a 12% boost just by swapping the motor, that's potentially disruptive.
Absolutely. It changes the whole design equation for car makers.
Yeah, it really could.
Now let's link that efficiency back to the environment, because that's arguably the deepest advantage here. Removing the rare earths. That cuts out the toxic mining, sure. Reduces CO2, waste.
Big win there already.
But maybe the biggest sustainability win is actually recyclability.
Okay. This is important and often overlooked.
Yeah.
Traditional motors, you've got copper wires wound tightly inside a steel casing, right? The problem is, copper and steel, their melting points are quite similar. So separating them efficiently is really hard. It takes a lot of energy, complex processes, high cost. Often those materials just get lost or, downcycled into something less valuable.
But AEM's design,
Yeah.
you said steel and aluminum.
Exactly. And aluminum melts at a much, much lower temperature than steel.
Okay. So
So you don't need some complex disassembly line. You can basically just chuck the whole motor unit into a furnace. The aluminum melts away cleanly, easily. It leaves the steel parts behind. It makes recycling incredibly efficient, cost-effective, low waste. It turns the motor from being this end-of-life environmental problem into a properly circular resource.
That's a huge shift. And of course,
Yeah.
getting rid of those expensive, volatile, rare earths, that obviously cuts production costs. And maybe just as important, it reduces the risk for manufacturers. No more worrying about those sudden price spikes, which should make the final EV, cheaper and more predictable to build over the long run.
Definitely. So you've got better efficiency, lower risk, and this circular manufacturing potential. All those economic advantages should feed right into market adoption. Which brings us to the next big question. Is the industry actually buying into this? Is this real?
Right. Okay, let's talk market confidence then. The tech sounds great on paper, but like you said, engineering is only half of it. Scaling up is the real test. So, what signals are we seeing? Do automakers actually believe in AEM?
Well, the signals seem pretty strong, actually. Going to look at the money. Investment. AEM just closed a very successful Series A funding round. They raised $29 million, which is about 23 million pounds.
Okay, that's significant for Series A.
It is, and look who led it. Not just typical VCs, we're talking major institutions.
Yeah.
Legal and General Capital, Barclays Sustainable Impact Capital. When big players focused on climate and impact investing put that kind of capital in, it shows they believe in the commercial plan. They're betting on AEM's ability to scale this thing.
Yeah, that's more than just tech validation. That's market validation. They see it as key infrastructure for climate goals.
I think so. And then look at the partnerships. That confirms they're getting ready for mass production. AEM signed a major deal, multi-million-dollar, with a huge global auto component supplier.
Okay. One of the big tier ones.
Exactly. Billions in annual revenue. The name's not public, but securing a deal with a supplier that size, it means AEM is already being integrated into the high-volume supply chain.
And they're working directly with car manufacturers, too, the OEMs.
That's right. We know AEM is actively developing an EV motor with Volkswagen's luxury brand, Bentley.
Bentley. Okay, that's interesting.
Very interesting. Partnering with a luxury brand like Bentley is smart. Their standards for performance, for quietness, reliability, they're arguably tougher than the mass market. So if this magnet-free tech works for Bentley, the rest of the industry is definitely going to pay attention.
It gives them huge credibility, right? It shows this isn't just for, say, city buses or light commercial vehicles, although their motors are already being used in those applications, aren't they? Across Europe, North America, Asia.
Correct. They already have that commercial deployment. Millions of kilometers of real-world use, proving the tech works in demanding commercial settings. So the big question for consumers, when might this actually end up in a car you can buy?
Yeah, the timeline.
A target for widespread introduction in passenger cars and commercial vehicles is, well, it's ambitious, but it makes sense.
Yeah.
By the end of this decade, 2030.
That timeline is fascinating because it lines up perfectly with all the pressure that European, US, Japanese automakers are under. They have to overhaul their supply chains, reduce dependence on critical materials, especially from China. This tech could be the strategic shortcut they need to hit those 2030 goals for independence.
Yeah, and looking at the bigger picture here, this shift away from rare earth permanent magnets, you mentioned maybe 10 kilograms of copper and rare earths in a typical motor. Moving away from that, it kind of starts to redefine what we even mean what we call an EV green.
That's a great point. We're moving from just prioritizing, say, energy density or power density towards prioritizing materials that are abundant, ethically sourced, and critically easy to recycle. It's a shift in engineering philosophy.
It really is. So, summing up that part, we have what looks like a superior, more sustainable product. And the market seems to be validating it, right? Big investments, high-profile partnerships.
Checks those boxes.
However,
Yeah.
there's always a however with scaling tech. Continued success really boils down to two big operational factors. One, can they actually scale up manufacturing? Can they make millions of these things efficiently and reliably? And two, they need continued positive results from those performance trials, like the Bentley collaboration. The tech seems sound. Now, the execution at massive scale has to follow.
That's always the critical hurdle, isn't it? Manufacturing scale. But the promise here is huge. Okay, let's try and leave you, our listener, with the most memorable takeaways from this deep dive. We've talked about a new kind of electric motor, uses simple steel and aluminum, not those tricky rare earths. A motor that claims it could boost EV range by a significant 12%. And it's not just theoretical, they've already got deals in place, including that collaboration with Bentley.
And maybe here's the final provocative thought to chew on. If sustainability, supply chain security, and predictable costs become the main drivers for innovation in the next few years, could the future standard for EV motors actually be defined less by powerful exotic magnets and more by materials that are just simple, abundant, and super easy to recycle? Ponder whether the next wave of premium tech will be defined by what complex stuff it contains, or perhaps by the problematic stuff it cleverly omits.
That definitely reframes what premium or advanced might mean in the electric age. Well, thank you so much for joining us for this deep dive into AEM and the future of electric motors.
Yes, thank you. And we really encourage you to keep exploring this link between where materials come from and what truly sustainable mobility looks like. Until next time.